Hello, I'm Mr. Goan, and today we're going to be having a look at the National 5 Relationships Outcome 1.2, which looks at quadratic graphs in the form y equals kx squared, the key points of graphs in the form y equals x plus a all squared plus b, or the completed square form, and sketching quadratic graphs. So we're going to jump straight in with the 4 questions from Outcome 1.2's NAB. Now the first question is question 6. Now, question 6 is a 1-mark question. It starts off nice and simply. The diagram shows the parabola with the equation y equals kx squared. What is the value of k? Now, looking at that graph, we can see that several coordinates have been marked on. We've got -2, 8, -1, 2, 1, 2, and 2, 8. Now, we can pick any of those 4 points. We cannot use the point 0, 0 down here at the origin. This one won't give us a solution. Now we can do this fairly simply if we have the coordinate x equals 1, which we do, but to demonstrate I'm going to use one of the other coordinates just to show you it. Now to start with we have y equals kx squared, where we're being asked to find k. So if we use this coordinate here, the coordinate 2, 8. Now we know that coordinates take the form x, y. So what we have with this coordinate 2, 8 is actually a value for x and a value for y, and using that we can calculate our value k. So substituting in our numbers, we have that 8 is equal to k times 2 squared. Now 2 squared is 4, so 8 is equal to 4k. If we divide both sides by 4 here to get our k on its own, and I'm going to swap them around, we're going to get that k equals 2. Now the shortcut for this is if we have a coordinate where x is equal to 1, down here, the coordinate 1, 2, then when we do this sum, what we would get is that 2 is equal to k times 1, which is k, jumping straight to 2 equals k or k equals 2. Because it's a 1-mark question, you can state that if you can spot it straight away. Carrying on into question 7, the equation of the quadratic function whose graph is shown below is of the form y equals x plus a all squared plus b, where a and b are integers. Write down the values of a and b. Y equals x plus a all squared plus b is the completed square form that we looked at back in factorizing in expressions and formula. Now, write down the values of a and b. From this form, we should know that the turning point happens at the coordinate -a, b from the completed square form. So we're going to be working backwards this time because what we already have is the turning point. We can see it there, and we know that that turning point, TP, happens at 1, 3. What that tells us then is that -a is equal to 1, so positive a is equal to -1. And b, we already know, stays the same, so b is just 3. Now there's our marks for a and b, and we can write that back down again. We can say that y is equal to x minus 1 all squared plus 3. Don't need to state that just now, but in the final exam you may be asked to state it once you've found a and b. Moving on to question 8. Now question 8 is the largest question on here, but it follows the same steps every time. Now, you're not being tested on your ability to factorize, so the factorizing part of this question has been done for you. You've already been presented with this in the form y equals brackets x minus 4, close brackets, multiplied by brackets x plus 2, close your brackets. We've already been taken our trinomial and put it into a double bracket. Now, the steps for this are the same for each question. You might see them in a different order, but this is the order I do them in. We'll start by finding the y-intercept, and that happens when x is equal to 0. So when x is equal to 0, y is equal to 0 minus 4 times 0 plus 2. So y is equal to, that's -4 multiplied by positive 2, which is -8, giving us the point 0, -8. Next up, we need to find our roots, or the 2 points that this curve crosses the x-axis, because we know it's going to look something like this. We've already found our y-intercept. Now we need to find our 2 x roots. So those happen, as you can see, when y equals 0. So when y equals 0, x minus 4 multiplied by x plus 2 equals 0. Now we know that if you have a and you multiply it by b and you get 0, then either a is 0, b is 0, or they both were 0 all along. So we can use that information by saying that x minus 4 equals 0, or x plus 2 equals 0. And from that, the very simple one-step solving equations, we can say that x must be positive 4 or x must be negative 2, which again gives us coordinates. We now have an x-coordinate when y is 0 and a x-coordinate here when y is 0, giving us 3 coordinates so far. Now, the last coordinate we need is the turning point. Now, the turning point happens at either the lowest or the highest point on our curve. In this case, it will be at the lowest. But a parabola is symmetrical. That means that our turning point happens on the line of symmetry, and the line of symmetry is going to be exactly halfway between the 2 x-coordinates we've just worked out. So we need to find our midpoint first, and our midpoint happens when x is equal to the sum of these 2 x-coordinates divided by 2. So I can take my 4 and add it to negative 2 and divide the whole thing by 2. So we get that x is equal to 4 plus negative 2 is 2, divided by 2 is 1. So now we know our line of symmetry is the line x equals 1. We can take that x equals 1 and find where our curve crosses it by substituting it back into the formula. Y equals 1 minus 4 times 1 plus 2. So that's negative 3 times positive 3, so y equals negative 9, which gives us the coordinate 1, negative 9. What we now have is 4 coordinates. We've got a y-intercept, we've got our 2 x roots, and we have our turning point. So we can now plot this. Now the question specifically asks us to plot it onto plain paper, and during the exam you would have plain paper. Now some of you might be doing this on squared paper. All I would ask is that if you are, that you draw your axes as neatly as you can using a ruler. Now I'm going to cheat because I'm digital, but looking at our coordinates, we know that our y's are either negative numbers or they're zeros. So we're going to have a mostly under the x-axis graph here. And our x-coordinates range from the lofty heights of 4 on the right-hand side to negative 2 on the left-hand side. So we're going to have much more space on our right-hand side here. Now before we begin, we should always start by labeling our axes. So we've got the y-axis, the x-axis, and I'm going to label 0 in here as well. Now, my preference is to find my turning point first, because from there everything else is symmetrical. It's also my lowest point in this question. And it gives me an idea for judging where everything else should be. So I'm going to say that 1, negative 9 on my scaleless axes is going to be about here. I'm going to label that turning point 1, negative 9. And from that turning point, I'm going to draw a dotted line. Straight up, my line x equals 1. And that is my line of symmetry. Now I'm going to plot on my y-intercept because that happens at 0 and negative 8. So I'm going to say that's about here with 0, negative 8. And finally, my 2 x roots, which happen at 4, 0, and negative 2, 0. So if that we're saying is 1, then 2, 3, 4, 4, 0. And if we're going to say that this is a line of symmetry, then the distance from my 4, 0 to the dotted line should be the same again out to here for -2, 0. And actually I'm going to write that underneath. Oh, of course, it's moved the point. 1 second. I'm going to move that coordinate to underneath like that. Now it won't be in the way when I draw my curve. Now, as neatly as I possibly can, I'm going to connect all of these dots in as smooth a curve as I can make it. And I'm going to apologize ahead of time because I know I get quite shaky when I start drawing these. So, turning point, and now straight the way back up to 4, 0, like so. And our curve should go through the point because it doesn't just stop at these two roots. It would continue on if we were to plot more points. And that's not too shabby. Nice curve there. A little bit of a wobble, but that's okay. And that's that question done. We've got marks for calculating the y-intercept and the roots, marks for the turning point and marking it clearly on our graph, and the mark for the graph itself with all the appropriate points and axes labeled. As I've said, you should draw in your line of symmetry. A dotted line's fine. Now, last up on this one is question 9. A parabola has the equation y equals x minus 2 all squared minus 7. Write down the equation of the axis of its symmetry. And B, write down the coordinates of the turning point on the parabola and state whether it is a maximum or minimum. Now, of habit, I normally find the turning point first, but we'll have a look at this because we know that for A, the equation of the axis of symmetry happens when x equals -a. And we can see already that we've recognized this as a completed square form. Y equals x plus a all squared plus b. So this minus 2 in here is our plus a. So if x happens at -a, then x must equal -2, which is +2. B asks us for the coordinates of the turning point, and we know that the turning point happens at the coordinates -a, b. We've already established that -a is +2, and b remains unchanged. It's this additional bit added on to the end here. We've added on -7, so our b coordinate is -7. There's our turning point. Now, we also know that a positive x squared coefficient gives us a smiley parabola, which is a minimum turning point. A negative x squared gives us a frowny parabola. Negatives are frowns, positives are smiles. So this is going to come out as positive x squared. So that should tell us that we're going to have a minimum turning point. See? Positive x squared. Minimum turning point. And that's all there is to it for outcome 1.2. Good luck.